What's up, everyone? Today what we're going to look at is the nth term of sequences, specifically arithmetic sequences. By the end of this video, you should be able to find the nth term of both a linear and a quadratic sequence. So let's look at the first example. Here are 5 terms of an arithmetic sequence. We got 3, 9, 15, 21, and 27. So what is the nth term of this sequence going to be? Because it's an arithmetic sequence, the word arithmetic basically means it adds each time. And we can see that it adds each time, but what does it add by? So let's first and foremost find the common difference. So let's write down our sequence. We've got 3, 9, 15, 21, and 27. And now let's work out the common difference. So 9 minus 3 is plus 6. Here, 15 minus 9, plus 6. And here again, we go plus 6. And 27 minus 21 is also plus 6. So because we have a consistent plus 6 with each of our terms, we know that the nth term of this sequence has plus 6n to it each time. Now, it's not just going to be 6n, it's going to be 6n and something. But what is that something? Now what we need to do is we need to have this sequence and we subtract 6n. To do that, what we're going to do is we're going to rewrite our sequence. So we've got 3, 9, 15, 21, and 27. And we're going to subtract 6n. So, from 6n, what is the first term going to be? When we sub in 1, right? 6 times 1 is 6. When we sub in 2, 6 times 2 is 12. And then it's 18. And then it's 24. And then it's 27. It's 30. Excuse me. 27's up here. And now we subtract. So 3 minus 6 is minus 3. 9 minus 12 is minus 3. 15 minus 8 minus 3. Minus 3 minus 3. And so our final solution for the nth term is going to be 6n minus 3. And that is our final answer. Let's look at another example if that one didn't make sense. Here are the first 5 terms of another arithmetic sequence. Find an expression in terms of n for the nth term. So let's write down our sequence again. We've got 16, 19, 22, 25, and 28. What's the common difference? 19 minus 16 is plus 3. 22 minus 19 is plus 3. 25 minus 22 also plus 3. And 28 minus 25 also plus 3. So therefore, our nth term has in it plus 3n. Okay? So now we have this one, our original sequence, and now we need to subtract it by 3n. So let's rewrite it. We've got 16, 19, 22, 25, and 30. 28, excuse me, that's 28. And now let's put 3n there. Our first term is going to be 3 times 1, 3. Then it's 6, then it's 9, then it's 12, then it's 15. And now let's subtract. What is 16 minus 3? 16 minus 3 is 13. 19 minus 6 is 13. 22 minus 9, also 13. 13 and 13. So our nth term is going to be 3n plus 13. Yeah? But what about something like this? The first 5 terms of this sequence are 4, 9, 16, 25, and 36. What's the nth term going to be? So, what we can do is we can check by how much are they adding by. We got 4, 9, 16, 25, and 36. So let's find the difference. 9 minus 4 is 5. 16 minus 9 is not 5, it's 7. 25 minus 16 is 9. And 36 minus 25 is 11. Now, what do you notice about this? Exactly. It also has a common difference, doesn't it? It has a common difference of 2. So what we can do is we can say that this sequence has a 2 divided by 2. We always divide by 2, which is 1. So this term has a n squared term. Yeah? And just like last time, we're going to subtract n squared from our original. So we're left with 4, 9, 16, 25, and 36. And we're going to subtract by, what do we have? We got 1 squared, which is 1, 2 squared, which is 4, and we're left with 9 squared, 9, 16, and 25. When we subtract, we're left with 3, 5, 7, 9, 11. Okay. And now what we're going to do is we are going to find the nth term of this equation. So what's the common difference? The common difference here is 2. So therefore, 2n is a part of this equation. And so therefore, I am running very low on space. We're going to subtract this 2n from this, because this is now the sequence that we're looking for. So let's rewrite it. We got 3, 5, 7, 9, and 11. And also we got 2, 4, 6, 8, and 10. And we're left with 1, 1, 1, 1, 1. So our final nth term is n squared plus 2n plus 1. Just so we can double check, let's substitute in 3. Why not? We got, when n equals 3, right? 3 squared, 9, plus 2 times 3, 6, plus 1 is equal to 16, which is right here. Just so we can double check. This is so we double check. Now, we're told to find the 10th term. All we're going to do is n is going to be equal to 10. And so therefore, 10 squared plus 2 times 10 plus 1 is simply going to equal 100 plus 20 plus 1, 121. And that is our final answer. These two right here. Okay, what about something like this? How are we going to work it out? So, again, as has been a common theme, all we're going to do is we're going to find the difference. So, we got 20 minus 11, 9. 35 minus 20 is 15. 56 minus 25 is 21. 83 minus 56 is 27. what's the common difference here? The common difference here, well, let's take a look. 15 minus 9 is equal to 6. 21 minus 15 is equal to 6. 27 minus 1 is equal to 6. 6 divided by 2 is equal to 3. And so therefore, this sequence has 3n squared. Okay? So now what we're going to do is we're going to sub in 3n squared and we're going to subtract it from 11, 12, 35, 56 and 83. So let's take a look. We got 11, 20, 35, 56, 83. And we're subtracting it from 3 times 1 squared is 1. I'm going to put it in red. Times 3 is 3. 2 squared is 4. Times that by 3 is equal to 12. 3 squared is 9. 9 times 3 is 27. 16 times 3 is equal to 48. And 25 times 3 is equal to 75. So now let's subtract. 11 minus 3 is equal to 8. 20 minus 12 is equal to 8. 35 minus 27, also 8. 56 minus 48 is 8. 83 minus 25 is 8. So what we're left with is plus 8. So our final solution is going to be 3n squared plus 8. Thank you guys very much for watching. I hope that this video made sense. If you guys liked it, please consider subscribing as it would help out the channel a lot. If you guys want some personalized help, join my Discord server and send me whatever questions you want. If you have any other inquiries about tutoring, drop me an email and we can organize a quote. Keep on learning, as you have no idea what you're capable of doing. Holy fuck, why can I not record today? Ha ha ha, that joke is older than Avazand and okay, give us food, please.